Hi guys, today we're going to talk about specific heat capacity. We have a situation right here in which 150 grams of lead is being heated to 100 degrees Celsius initially. Then lead will be placed into this beaker that is isolated right here. This beaker has 50 grams of water in it, which had an initial temperature of 22 Celsius. And what happens after you add the lead? The temperature will be increased. Now, the first step that we do right here is we identify the substance that releases energy and the other substance that therefore absorbs energy. Why is that? Because the main equation that we'll use is Q absorbed or heat absorbed equals heat released. So we need to identify which one absorbs and which one released energy. Yesterday we were saying that the substance with the greater temperature is the one that releases temperature. Therefore, is the one with a negative because it's losing energy. And now the one with the least temperature is the one that absorbs. So, knowing this, you can identify that lead is the one that releases and water is the one that absorbs. Now, what is the next step? We need to write the givens. So what we do is we're gonna write the givens apart. What do I need? I need mass, I need specific heat capacity, and I need temperature. But not just temperature, I need change in temperature, which means that I need, remember, delta change in temperature is final minus initial condition. Now, I need masses of both, of water and of lead. So, my lead's mass is 150 grams. My water mass is 50 grams. As it is in grams, we're going to do a conversion, but not yet. Then I don't have the specific heat capacity of lead, so this is what I'm looking for. But I know that for water is 4,186 joules over kilogram degrees Celsius. This is a given, it's in the table, which is in the presentation that I gave you. Then we have delta T, and delta T involves final and initial condition. So the final and the initial condition. Initially, lead was at 100 Celsius. And the final temperature is right here when they both reaches the thermal equilibrium. So we have the final temperature to be 28.8 degrees Celsius. Now, the thermal equilibrium means that is the final temperature for both substances. So the final temperature will be the same for lead but also for water. But my initial temperature of water was different. If we take a look of the image here, we have the initial temperature of water to be 22 degrees Celsius. Now I need to find specific heat capacity of lead. So what we're gonna do is we're gonna apply this equation right here. This is the solution already, okay? So I'm gonna place it right here. Now, so I say my first step is solution. So I have my first step to be Q absorbed equals negative Q released. Which one absorbs? Water. Which one releases? Lead. Now, In this side of the equation, I will write my mass, my specific heat, and my change in temperature of water. Sorry, I forgot. I said that we had to convert from grams to kilograms, so we need to divide by 1,000. So this will be 0.05 kilogram times a specific heat capacity of water, that is 4,186 joules over kilogram Celsius. And I have here my change in temperature, that is final minus initial. This is equals to negative lead, that is 150 kilograms in 150 grams in kilograms is 0.15 kilogram. The specific heat capacity, that is what we want to know, and the change in temperature, that is final minus initial. But this is for lead, okay? This is for lead, okay? Now, you can start solving this. Okay guys, you place in all your givens. Here I had a mistake, so I have to use my liquid paper. And what do I suggest? Solve for the change in temperature. Solve for this first and then multiply. After you have solved for your changes in temperature, remember that we still need to find the specific heat capacity. After you have solved for the parentheses, subtraction right here and there, here 28.8 minus 100 gives you negative 71.2, and here gives you 6.8. Now do the math in your calculator and write the answer. This gave me 1423.24. Now, what are the units that we're gonna write right here? So take a look. My kilograms right here are gonna be cancelled with this. My Celsius from my specific heat capacity is going to be cancelled with Celsius from the change in temperature. So Q, it's heat, and heat is measured in joules. This is going to be equal to the other side of the equation. 0.15 times 71.2, both of them negative, gives you negative, gives you positive. So this gave me 10.68 CP. Now, I want to isolate specific heat capacity, so this 10.68 is multiplying, so I'm going to send it to the other side, dividing. I'm going to have 1423.24 joules divided by 10.68. Now, in what unit is this? Kilogram Celsius. If you take a look, these two are multiplying. This is equal to my specific heat capacity of the one that releases, that is lead. Now do the math. 1423.24 divided by 10.68. Okay, so I have my specific heat capacity of lead equals 133.26 joules over kilogram Celsius. That's your answer, guys. Then you can compare the table of specific heat capacities. If we see that our answer makes sense, so probably it's because we did it right.